One of the common and important application of free body diagram is the motion of connected system. So let's take an example of that. Let us say there are two masses m1 and m2 which are connected at the ends of a light inextensible string that passes over a frictionless pulley. We have to find out the acceleration of the masses and the tension in the string when you release the masses. Now let us say that your mass m2 is greater than m1. Now in such a case, your system will move in this direction, let us say with an acceleration a. Now as we have seen in earlier example also, we have to draw the free body diagram. Now when we have to draw the free body diagram, we have to follow steps. So first step is to identify the system. So here our system is consisting of two masses which are connected with a string. Step 2 is to write down all the forces acting on the bodies. So let's start with that. Now for your mass m2, weight is acting downward and the other force which is there is the tension which points away from the body. Now for mass m1, weight is acting downward and the tension in the string is acting away from the body. Okay, so now our forces are also marked. So let's move to the free body diagram. So we'll draw the free body diagram of the two bodies separately. Now starting with m1. So here is your mass and let's mark the forces. One is your weight, the other is tension. For mass m2, the diagram will be similar, that is the tension is acting upward and the weight is acting downward. Now after drawing the free body diagram, we know we have to find out the net force. Now when we are finding net force, we have to take into account the direction of acceleration if the body is in motion. Now if you see the system again, the body m1 is going up and the body m2 is going down. So the acceleration for m1 you will draw in the upward direction and the acceleration for m2 you will draw in the downward direction. Since the system is connected, so we are taking the acceleration as same, that is a for both the bodies. Now after this, the next step is to write down the net force. So m1 is going up, so net force is definitely acting in the upward direction. How many forces are there? 2. So net force is nothing but T minus m1g. Now what we have to do after this? We have to equate this net force using Newton's second law with mass times the acceleration. Okay, same way we can write it for m2, that is since the body is going down, so net force is acting in downward direction. That means your m2g is more than tension. So m2g minus t is the net force and we have to equate it to mass times acceleration. Now let us say this is our equation 1 and this is our equation 2. So there are two variables here right now and we have two equations. The variables are tension and acceleration. So for finding tension, what we can do is that for tension we can divide these two equations. So let us say equation 1 divided by equation 2. So what do we get? So this is equal to 2m1 m2g. So T we have got as 2m1 m2g upon m1 plus m2. Okay, so now you have tension with you. What you can do, either you can substitute this value of tension in equation 1 or 2 and you can get the value of acceleration. There is another way also to find out acceleration. What we can do, we can simply add the two equations, that is equation number 1 and 2. So let's see what do we get. So if I add equation number 1 and 2, so I can write here adding equation 1 and 2, we get T minus m1g plus m2g minus T is equal to m1a plus m2a. So as you can see on the left hand side, t will get cancelled and we will have m2 minus m1g. And on the right hand side, I have m1 plus m2 into a. So acceleration of the system is given by m2 minus m1g upon m1 plus m2. So whenever you have a system like this, let us say for example you have a pulley and you have one mass as 5 kg and the other mass as 10 kg, and you are supposed to find out the tension of the system in the string, and you have to find out the tension in the string and the acceleration with which the system will move when the masses are released. So you can either use these formulas directly or you can use a free body diagram method. What do we mean by that? That means you simply write the equation for the two body. Now this is your 5 kg, so your weight is acting downward, so m1g, and tension is acting upward. So what is the equation? Now you can do it, you know. This is the direction of A, so the equation will become, this is going up, so it is T minus 5G is equal to 5A. Now similarly, if I write down the equation for second body, now this 10 kg, again weight is 10G upon and 10G, and in the upward direction it is tension, and this body is going down with an acceleration A. So this will be 10G minus T is equal to 10A. So you can see it is very simple. Now for tension, I will simply add, let's say this is 1 and this is 2. So if you simply add these two, what do you get? 10G minus 5G, that is equal to 5G only, and here it is 15A. So A is nothing but 5G upon 15. So you can put the value of G as 10 or 9.8 and you can get the value of acceleration. Same way you can find out the tension. The other way is that you apply the formula, this formula of acceleration and tension, that will save your time. So if you can remember the formula, you can substitute the value here. Thank you.